imaginary star on meridian would be so much. SHA of the respective star is as tabulated here. The difference between these two for respective stars shall give us the R angle P. So this R angle P for Spica is the difference between 169 degrees 38.6 minutes and 158 degrees 47.7 minutes. Likewise, we have got the R angle for all the stars.
So what have we done, beta? We have found out the difference between the SHA of the star, which is column number 2, and the SHA on our meridian, which is 169.38.6. And this difference is written down here in the last column for each and every star. So is that clear, beta?
Sir, that Pika value
Yes, sir.
for Jackrax also coming, when we are subtracting, should be coming on minus, I think, before this X meridian limit, na, sir?
That's right, beta. It will come in minus, but here we are taking only the difference. So bigger minus smaller, plus or minus does not matter.
Okay, sir.
Right. Okay, so let's proceed ahead.
Yes, sir.
Sir, sorry to disturb,
Next,
sir. Sir, excuse me, sir. Sorry to disturb,
Go ahead.
sir.
Go ahead.
I just
Go ahead.
joined in now because of the net was not there, sir. So just this SHA of on meridian, from where are we getting that, sir? Like, can you just briefly can you tell me, sir, please?
Okay, beta. Beta, you remember when we started the question, the first thing which we calculated was the SHA of an imaginary star on the observer's meridian, right?
Yes, sir. Yes, sir. Yeah.
It is exactly that same SHA, beta.
Okay. ठीक है, sir. ठीक है.
So this value is basically giving us the SHA corresponding to the observer's meridian.
Okay, sir. Got it, sir.
Okay.
Get is the time to Marpas or time from Marpas by dividing this R angle by 15 degrees 02.5 minutes. When we divide, we get time to or from Marpas as shown here. This is 43 minutes 16 seconds and we have time for other stars also. Now we use.
Okay, now let's try to understand this better. Now you have a look at the first star. The SHA of the star Spica is 158.47.7 and the SHA of our meridian is 169.38.6. Difference between them is 10 degree 50.9 minutes. It basically means Spica has to cover 10 degree 50.9 minutes of R angle to come on our meridian. Agree, beta?
Yes, sir.
Right. Now we know Spica moves at a rate of 15 degrees 2.5 minutes. So if you divide this value 10 degree 50.9 by 15 degrees 2.5 minutes, please do that in the calculator, beta. You can do that, punch in the numbers and see if you are getting this answer, 4316.
Yes, sir. 43 degrees 16 seconds. 43 minutes 16 seconds.
Right, beta, right. So likewise you see we have obtained the time for each and every star. Number 2 star Elliot is going to take 12 minutes 16 seconds to come on our meridian. Mimosa will take 5 minutes 52 seconds to come on our meridian, and Gekrux is going to take 10 minutes 38 seconds.
Sir, that
last
is the before meridian passage, na sir, 10 minutes before meridian passage.
That is right, beta. I'll tell you. For Spica, Elliot and Mimosa, this is time to meridian passage because these stars have not yet come on our meridian. They will be coming on our meridian in this time. Gekrux has already crossed our meridian, beta. Because our meridian was 169, Gekrux is already on 172. So after Gekrux has crossed the meridian, 10 minutes 38 seconds have passed.
Yes, sir.
Okay, but we don't need to bother about whether a star is east of our meridian or west of our meridian, yet to cross or already crossed. That is not required, because the x meridian limit is applicable on both sides, before Marpas also and after Marpas also.
Okay, sir.
Okay, so any doubt up to here, beta?
Sir, is the method different from what is given in the Subra? Because I'm not able
Beta,
to correlate.
with due respect to Subra sir, आप प्लीज ये वाले चैप्टर के लिए ना बुक को रेफर मत करना, बिकॉज मैंने सबसे पहले उसी बुक को रेफर किया था एंड आई हैड टू स्पेंड 2-3 डेज बिकॉज सारे के सारे क्वेश्चंस के आंसर्स गलत हैं. ओके, सो
नहीं
प्लीज
सर,
फॉरगेट.
वो क्वेश्चंस नहीं सॉल्व कर रहा, मैं बोल रहा हूँ इट्स अबाउट द मेथड एक्चुअली. उन्होंने LHA ऑफ एरीज प्लस SHA ऑफ स्टार इज इक्वल टू LHA ऑफ स्टार निकाला है एंड देन ही हैज सबट्रैक्टेड इट फ्रॉम 360 डिग्रीज.
It is basically getting to the same thing through a slightly different method, but I would recommend doing this way. This is much easier to understand, beta.
Yes sir, no problem. I was just asking whether that part is also like, since I have solved using that earlier in my exam, like in my notes. So
Okay, if you are comfortable with that, you can do that also. Basically, what have they done is, I'll tell you. Instead of comparing the SHA, they may be comparing something else. Okay, they may be the LHA.
LHA is a SHA star.
Right, so that also can be done. But
And that's how they get LHA star value. I think that is the Pika value that they are calculating as LHA star.
Exactly.
Yes, sir.
But whatever method you use, the value of P will remain same, beta. It will not change.
Yes, sir.
yeah, okay sir. Your method looks much simpler. So I only just wanted to clarify.
Okay, all right. So now we have obtained the time, how far away all these stars are from our meridian. Let's proceed ahead now.
Use nautical tables and get the x meridian limits using the nautical tables. We have used the Norris tables to get the x meridian limits. So these x meridian limits are as per the Norris table: 29 minutes for Spica, 44 minutes for Elliott, and the others as listed. We compare these x meridians limits obtained from nautical tables with the time to or from Marpas that is calculated, and what do we find? Except for Spica, which is outside the x meridian limits, the other three stars, Elliott, Mimosa, and Gekrux, they all are within the x meridian limits, and therefore these three stars are suitable for x meridian observation.
Okay, so let's see what we have done here. Now beta, in the next column, we have obtained the x meridian limit for each of these 4 stars. How do we obtain the x meridian limit? Using the x meridian tables, table 1 and table 4. The limit for the first star, Spica, is 29 minutes. And Spica is right now 43 minutes away from our meridian. So will it be suitable for x meridian site?
No sir.
No, sir.
Very good, beta. Now if you look for the second star, Elliott, Elliott is 12 minutes away from our meridian, and its x meridian limit is 44 minutes. So it is very much within the limit.
Yes sir.
And it is suitable. Similar likewise for Mimosa and Gekrux. The stars are 5 minutes and 10 minutes away. Their limits are 61 and 60 minutes, so they are well within the limit, and that is why suitable for x meridian. So this is how we check the suitability for x meridian observation. Now have a good look at the table, beta. Let me know any doubts coming anywhere.
Sir, SHA on meridian, from where it came, sir?
बेटा हमने जब ये क्वेश्चन सॉल्व किया था ना, द फर्स्ट थिंग विच वी ऑब्टेन्ड was the SHA of an imaginary star on our meridian, right?
Yes, sir.
This is that same SHA.
Okay, sir.
सर ये एक्स मेरिडियन लिमिट ना थोड़ा कंफ्यूजिंग लग रहा है सर, ये हाउ आर वी कमिंग टू दिस लिमिट 29 सर, ये कैसे डिराइव कर रहे हैं सर?
Okay, बेटा do you have the X meridian table with you? मैंने आपको सॉफ्ट कॉपी भेजी थी और द हार्ड कॉपी, एनीथिंग डू यू हैव?
मीन टू से नूरी सर,
हाँ दैट्स राइट, नॉरीज टेबल.
सॉफ्ट कॉपी है सर, सॉफ्ट कॉपी सर.
Okay, just open it up beta. Just open it up and go to X meridian table 1. You can see it in the index. Go to the page number. Let me know once you are there. Other people also, if they have the tables accessible, they can follow me.
Page is 432, sir. 432.
Very good. Page number 432. Please go there beta.
जी सर,
Oh.
यस यस.
Right beta. Now beta table 1 में आप देखोगे it is divided into two parts. One is lat and deck same name, another is lat and deck opposite name. So now tell me for Spica, lat and deck are for the same name or opposite name?
Opposite name, sir.
Very good. So enter into opposite name and go for a latitude of 20 north, declination 11 south. So you are getting a value of 3.5 for 20 north and 11 south, right?
करेक्ट सर.
Okay, so factor A is 3.5. So now beta go to X meridian table 4 and look for the limit against 3.5.
Sir.
Very good beta.
जी सर, यस सर, गॉट इट.
Obtained. So doubt clear beta?
यस सर.
Very good. Great. Any more doubts?
नो सर.
Excuse me, sir.
Bolo beta.
Just to confirm, sir, this magnitude 1 and 2 means we include 1 and 2 also, no? Both.
हाँ बेटा, मैग्नीट्यूड तो मैंने 3-4 बार
थोड़ा कंफ्यूज हो गया. हो गया
नो प्रॉब्लम, नो इश्यूज. मैं अभी दिखाता हूँ तुम्हें.
नहीं वो हो गया सर.
हाँ ये देखो बेटा, these are the magnitudes. So if you see, first magnitude includes 1.0, second magnitude includes 2.0, third magnitude includes 3.0 and so on.
Yes.
Okay.
So इसमें we have to include till 2 sir, 1 and 2 both.
That is right beta.
Right.
That's right.
हाँ जी. Okay sir.
Okay. So we are here now. The X meridian question is done. So let's proceed ahead. All okay up to here beta?
Sir, for the X meridian, we have to calculate visible, it's visible or not and suitable for sight also.
That is right beta. Visibility and suitability has to be checked beforehand, because only those stars will be available for X meridian which are visible and suitable for sight.
And sir, that 15-degree limit for the observer's meridian also useful for that? If we are going to meridian this observation.
No beta, we will use the limit which is given in the question. If the question, in this question, they stated a limit of 20 degrees, then we would have picked up the stars with a 20-degree limit, beta.
Okay. For that, okay, sir. Actually, I was thinking something else. Okay, sir. Got it, sir.
Okay.
Sir, so if a question comes in the exam for X meridian, then these all table we need to make.
That is right, beta. ये पूरा टेबल आपको बनाना पड़ेगा.
Okay, sir.
Okay, great. Let's move ahead now.
For X meridian observation. Now, in some questions, if the R angle, like in this case, it was given to find the stars which are within 15 degrees of observer's meridian. Now, if this angle, R angle limit is not given in the question, then, and we have to perform this check for X meridian observation, then we can check the stars falling within 20 degrees of R angle from observer's meridian. So if this limit is not contained in the question, you can set this limit at 20 degrees and carry out a check that shall suffice our purpose.
Okay, so have you understood this last point also, beta?
Yes, sir.
Okay,
It
great.
was not audible clearly, sir. Basically, if it is not 15 degree, we have to observe it for 20 degree R angle, right, sir? Like the limit should be 20 degree. That's what.
If it is not mentioned, then only.
If you get a question where the R angle is not mentioned, they have just told you to get the star suitable for X meridian and the R angle is not given in the question, like this 15 degrees was given here. So in that case, you will be in doubt that how far away from the meridian should I be checking the stars. So in that case, you can take a value of 20 degrees within 20 degrees of the observer's meridian and solve the question, because outside 20 degrees there will be no star suitable for a X meridian observation.
Okay. Yes. Okay. Clear, sir.
Okay, so you have to remember this figure of 20 degrees. Okay, great. So this was type 3 beta. Now we have done type 1, type 2, type 3, all building up on the same question. Now the remaining two types are different questions. Till now we were discussing stars within a certain R angle of the observer meridian. Now type 4 and 5 ask us to find the stars crossing the observer meridian in a interval of time. So these questions are slightly different now. So we will be taking up a fresh question and understand.
Now, there may be situations or questions in which we may have to find stars and planets which cross observer's meridian within a given interval of time. For example, this one, in position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing observer's meridian between 1800 hours to 1900 hours ship's time, zone time minus 0800 hours on 21st September 1992.
So you see beta, the question is changed now. Now the question is asking us to find the stars crossing our meridian within this interval. So it is changed from the one which we saw earlier. Earlier question wanted us to find the stars within a certain R angle. This question wants us to find the stars crossing the meridian. So is the question clear?
Yes, sir.
Okay, great. Let's see this type of question now, how to solve it.
To handle such questions, we need to obtain the SHA of an imaginary star on the observer's meridian, both at the beginning of the given interval and at the end of the given interval. So we get two SHA values of this imaginary star. One, when it is on the observer's meridian at the commencement of the interval, and second, when it is on the observer's meridian at the end of the interval. We know how to calculate the SHA of imaginary star on the observer's meridian. We can equate the LHA of that imaginary star to 360, and this LHA is equal to LHA Aries plus SHA of the imaginary star. We have already calculated in the first question, and we can repeat that process out here. If the duration of time is not given in the question and it is only AM or PM twilight, then for AM cases, the interval used is between the starting time of the nautical twilight to the starting time of the civil twilight. So that shall become the interval. Commencement of the interval shall be at the onset of nautical twilight, and the ending of the interval shall be at the start or onset of the civil twilight. For PM cases, this interval shall be between end of civil twilight to the end of nautical twilight. We can identify the stars and planets within the SHA range thus obtained, corresponding to the magnitude of stars and planets that is given in the question. Now, all the stars within this range shall be crossing the observer's meridian during the given interval. Whether they shall be visible or not, or whether they shall be suitable for taking sight or not, or whether they shall be suitable for X-meridian observation or not, we know once we get a comprehensive list of all the stars and planets, we can do the further analysis depending on whatever may be expected of us in that particular situation or particular question.
Okay, now beta, all these steps we will be practically doing in this question. You can have a look and let me know if any doubts are there.
So this LHA star value, we are taking 360 degree when it's on observer's meridian or on the X meridian. Both the times we are taking as a 360, no sir?
सी बेटा, जो पहला क्वेश्चन हमने किया था उसमें हमारे पास एक ही टाइम दिया गया था, ओनली वन टाइम. So we found out the SHA of an imaginary star for that particular time. We got only one SHA of a imaginary star on the meridian. Now in these type of questions, they have given us two times, starting and ending. So we will do that exercise for starting also and for ending also.
Yes sir.
So we will have two LHAs or two SHA of the stars.
Yes sir. Sir, I'm just asking this LHA star value, sir. SHA star we will be getting by applying in the formula this LHA Aries and LHA star we are taking as a 360 degree. So we are taking observer's meridian and X meridian, both the both the things we are taking as a 360 or 0 degree, na sir? LHA star ka value.
Right, beta. We are finding a star which is on our meridian. So whenever a body is on our meridian, the LHA will be 0 or 360. Any value can be taken.
Okay. No, actually, sir, that little confusion came on the type 5 question, that is upcoming question, inferior meridian. So little confused. Anyway, it's clear now, sir. It's clear.
We'll do that also, don't worry.
Yes, sir. Yes, sir.
Okay, let's go.
On whatever may be expected of us in that particular situation or particular question. So now we're in a position where we can solve this question. In position 40 degrees 10 minutes north, 121 degrees 15 minutes east, find the stars and planets of second magnitude and brighter crossing the observer's meridian between 1800 hours to 1900 hours shift mean time, zone time -8 on 21st September 1992. So we first find out the GMT at the commencement of the required interval and GMT at the end of the required interval. So the starting time, ship's mean time is 21st day, 18 hours. Zone time, -8. And we get GMT, longitude is GMT least, 21, 10, 0, 0, 0, 0. So we get the GMT at the commencement of the interval. Likewise, we calculate the GMT at the end of the interval, 21, 19, 0, 0. Zone time -8, and we get GMT as 21 day, 11 hours, 0, 0 minutes, 0, 0 seconds.
Okay, so beta, up to here, any doubt, please let me know.
No, sir.
No doubt, sir.
Very good, great.
Now we get the LHA Aries for these two GMTs. So at the starting time, GHA Aries for 21 hours, 21 day, 10 hours is so much. Increment is 0 because it is 0 minutes, 0 second. We get GHA Aries as 150 degrees, 31.9 minutes. We apply observer's longitude to it. Longitude east, GHA least, we add the longitude, and we get the LHA at the commencement of the required interval as 271 degrees 46.9 minutes. That is the LHA Aries at the commencement of the interval. We get the LHA Aries at the end of the interval. You can see the values coming up on the slide. You can also check them from your almanac. And we get the LHA Aries at the end of the interval.
Okay, so beta, we have just referred to the almanac for these GMT times and obtained LHA Aries for the starting time as well as for the ending time. So any doubt up to here?
No doubt, sir.
Very good, beta, great.
Now we find out the SHA of the imaginary star on the observer's meridian at the starting of the interval and at the time of the ending of the interval. So for imaginary star on the observer's meridian at the commencement of the interval, LHA star, which is equal to 360 degrees, will be equal to LHA Aries of 271 degrees 46.9 minutes plus SHA star, which gives us the value of SHA star to be 088 degrees 13.1 minutes at the commencement of the required interval. Exactly the same way, we can get the SHA of the imaginary star on the observer's meridian at the end of the interval.
Okay, now what we have done, beta? We have obtained the SHA of a star which is on our meridian at 1800 ship's time and also at 1900 ship's time. The first star which you are seeing having a SHA of 088 13.1, this will be on our meridian at 1800 hours, and the second star with SHA 073 will be
हैं?
नीचे आ एक बार
क्या हो गया?
आ जाएगा नीचे
मैं क्लास ले रहा हूँ अभी, बाद में आता हूँ।
क्लास
हैं?
क्लास नहीं चल खत्म हुई क्या अभी
नहीं आता हूँ बाद में।